In this problem, you're supposed to prove that the expression matches the area. So when I see this expression 2 times 3 plus 4, what I'm going to do is I'm going to try and see where do I see this information in this compound figure. And I see 2 times 3 here is the length and the width of rectangle 1. And then I have to add in, figure out where they get in the add-in just plus 4. And I see that the area of this is 4. And the reason I can just add 4 is that 4 times 1 makes 4. That's the identity property at work. So I see that this plus 4 comes in. So if I were to write this, I would say the 2 times the 3 is the length times the width for the first rectangle. And the plus 4 comes in from the second rectangle because the identity property is being used. We do not have to put the 4 times 1 to finish off the expression. In this problem, it's asking me which expression matches the area of the diagram. So I see that I have a 2 on this side, which also means that I have a 2 on this side. So technically, I have 2 times 5 plus, that's the area of the first rectangle, plus 2 times 3. So I see that this is one area that matches. So just to be sure, I'm just going to put a check mark here. I'm going to take a look at the other ones. Can I see where this becomes 2 times the quantity 5 plus 3? I can, because the total length of this line segment up here is 5 plus 3. That's this part. And then I'd be multiplying it by 2. So that would match. So then I come over here to see if this expression matches. So I have 3 plus 5, and it happens twice. So here's a 3 plus 5, the length of this segment. And then again, it happens again here because I have it times 2. So this one also matches. So all 3 expressions match this area diagram. In this problem, it's asking me to combine like terms. So when I see here, I see I have a 10K and I have a minus 3K, and then I have add 5H. I circled the like terms. So in here, I would just have to subtract the coefficients. 10 minus 3 equals 7. So it becomes 7K plus 5H, and that would be combining like terms because the K and the H would be different values for those variables. And again, if you think about it as hands-on equations, you would have 10 pawns, take away 3 pawns because those would be the same thing. The H would have to be represented by something different. Okay, the directions for this problem are to simplify this expression. So remember, we can hide the 3, and we have 5 plus 3x. So what does that look like? That looks like a 5 plus 3x, or you could do 3x's if you wanted to, but I have to do that 3 times. So it's another plus 5 plus 3x plus another time 5 plus 3x minus 4x. So what I have to do is I have to look for all the like terms so I can simplify this. So I'm going to go ahead and do my constants first. 5 plus 5 plus 5 makes 15. And then I'm going to box in my x variables. I have one here, here, and here. And those are all adding. And then this one is a subtract 4x. So I'm going to go ahead and do the adding first. 3 plus 3 plus 3 makes 9. 9 minus 4 makes 5. So it'll be minus 5x, and that would be in simplest form. This one says Greg has Q quarters and P pennies. His brother has 4 times as many quarters and 8 times as many pennies as Greg. Write the sum of the number of coins they have and then combine like terms. So if right here I see the word sum, which means to add. So I'm going to add everything all together. So right now I have Greg has quarters plus he has pennies. Plus, his brother has 4 times as many quarters. So 4 times the quarters means 4Q. So he has 4 times as many quarters as Greg's. Plus, he has 8 times as many pennies. So that's 8 and P for his brother. So they wanted the sum and combining like terms. So I'm going to combine the quarters together. So I circle the quarters. So this quarter plus 4 quarters And if you recall, the coefficient in front of this Q means there's 1/4, so there's a 1 there. 1 plus 4 makes, they have 5 quarter values. Plus, here we would do the P's together for pennies. Remember, the coefficient in front of this P is 1, so 1 plus 8 is 9P. And this would be the sum and combining like terms. In this problem, it says Angelo is twice as old as Gina. Write this expression in 2 ways. So a couple of things we have to look for. Is where the equal sign is going to go. Okay, and we have to know the word twice. So what I have is I have 2 unknowns. I have Angelo and I have Gina. So when I write this, I'm going to have A for Angelo is, and twice means times 2. Twice as old as Gina. So we'll call it 2 and G. So Angela is twice as old as Gina. That's one way to write it. Another way to write it is Angelo is G plus G, because that's what 2 G's means, G plus G. So that would be a second way to write it. Okay, we're going to take a look at this problem in a couple of ways. One, I think the time may be a little bit confusing, but after you see it kind of play out, I think you'll be able to figure out that this is actually an exponent problem. It says in Tyrone's science class, he is studying cells. Cell A divides every 30 minutes. If Tyrone starts with 2 cells, how many cells we have in 30 minutes? So in this problem, I see that I have a comparison. So I'm going to go ahead and start with a table. And it's not necessarily going to be a ratio table because it's going to go up, but it's not going to go up proportionally, as you're going to be able to see. So we have the cells and we have the time down here. And so he starts with 2 cells. And at that time, it's 0 minutes because he started out with that, so there was no time that went by. And so it says the cell divides every 30 minutes. So if I go up by 30 minutes, and it divides itself, it says there will be 4 cells. Okay, and so if it goes up to 60 minutes, okay, so that's another 30 minutes, and then this would divide itself again, which would become 8. Okay, and if you notice, 60 minutes is equivalent to 1 hour. So I'm just going to write that down here so you can see it. So I think you can kind of see a little bit of a pattern growing here. If we do another 30 minutes, that's 90 minutes, and this would be 16 cells. And I got to keep going. And if I go up to 120 minutes, okay, that's going to now divide itself again. So I'm going to have 32 cells. And if I go up another, now this is 2 hours, so we still have to get up to 3 hours. So I have 150 minutes, and that's going to divide itself again, so it'll become 64 cells. And then if I go up another 30 minutes, it's 180 minutes, which is 3 hours. And then that divides itself again, so we would have 128 cells. That would be our answer. So let's take a look at what was happening here. And we talked about exponential growth. And every time it just kind of splits itself in 2, correct? So this is 2 to the first power. This was 2 to the second power, and so on. So this one, if I keep going to the third, to the fourth, fifth, sixth, seventh power. So how would I have been able to figure out that it was 2 to the 7th power? What I would look for is I would say, well, how many 30 minutes are in 3 hours? Well, there's 7 of them. So it splits itself by 2. That's my base because that's what's happening every time. And there's 7 30 minutes in 3 hours. So that would be, if you could see that, you could do 2 to the 7th power. Remember, if you're doing that on the calculator, you're going to do 2 and then the little caret button, and the 7 will help you get that it's equal to 128. Adam and his 2 brothers went to the zoo. Each ticket to enter the zoo cost $7. Adam bought 2 bags of peanuts for $4 each, and one of his brothers bought a lion poster for $12. So we want to go ahead and write an expression to represent this situation. So we've got a lot of things going on here. We know that each ticket cost $7, and how many people went? You have Adam and his 2 brothers, so 3 people went. So in order for me to find out the cost of that, I would have to do 7 times 3. Okay, now I'm not going to find the value of it just quite yet. Then it said Adam bought 2 bags of peanuts for $4 each. So those 2 bags of peanuts at $4 each would be $4 times 2. Oops, sorry, I was trying to get the value of it. Okay, so that's my bags of peanuts. And then each one of his brothers bought a lion poster for $12. So if each person brought, and one of his brothers bought a lion poster for $12. So there's only one poster at $12. So we have to go ahead and write this expression so that we can solve this to get the correct value. So I know through orders of operations that I have to do multiplication first. So I'm going to put in parentheses 7 times 3, and then I'm also going to put in parentheses 4 times 2. Those were the peanuts. This was the admission, this was the peanuts, and then I'm going to add to that 12, which tells me I have to do these two, find these two values first because they're multiplication, and then I need to add it together to get to the total. The pet store put the same number of hamsters in 6 cages. This situation is modeled by the expression 6n. What does n represent and what is the 6? The n represents the variable, and the variable is the number of hamsters in a cage, and the 6 represents the coefficient, which represents the number of cages. Tony bought 2 packs of 50 plates and 1 pack of 30 plates. Which of the following expressions could you use to find the total number of plates Tony bought? So what I'd like you to do here is not find, it doesn't have any expressions. I want you to come up with the expression. So if Tony bought 2 packs of 50 plates, that means he bought 2 times 50. And he bought 1 pack of 30 plates. So I don't have to multiply 1 times 30. I just have to add in the 30. And the reason I don't have to add or multiply 1 times 30 is because that's the identity property at work. So this would be the correct expression. 2 packs of 50 plates plus the 30 plates, and then how much that would equal would be to find the total number of plates. And you write an expression for the product of 5 and y. Product means to multiply. So in order to write it algebraically correctly, it would be 5y. You could write 5 dot y. You could write it with parentheses. You could write it with the x, whatever represents multiplication. Write an expression for 12 less than x. The key word here is less than, and then than also means something. Remember, than means to reverse the order. So less than means I'm going to do a subtraction problem, but instead x has to come first, so my correct expression would be x minus 12. We're going to identify the parts of this expression, 3c plus 12. In this expression, a variable is a letter, so I see the letter C, so I put C here. The constant is what doesn't change. That would be 12. Everything is going to have 12 added to it. The coefficient, remember co means to go with, goes with the variable. So 3 is the coefficient. And recall that terms mean that they're separated by plus or minus signs. So I see 1 term, 2 terms. How does the commutative property help us with math? You could say something like the commutative property allows us to rearrange the orders of numbers when adding or multiplying to help make our math easier. So we're allowed to flip around the order, or it doesn't matter what order we add or multiply, we'll still get the same answer. The area of a square is represented by the expression area equals side squared. If the side length of a square is 4, what is the area? So this is a substitution problem. So area equals the side, which is 4 squared. So I know that 4 squared is the same as 4 times 4, which equals 16. The surface area of a cube is represented by the surface area equals 6 times the side squared. If the side length of a cube is s equals 2, what is the surface area? So again, we're going to go ahead and substitute in, and this time we have to use orders of operations to solve. And, excuse me, there should be a 2 here. I'm sorry. So 6 times 2 squared, let me rewrite that. 6 times 2 squared. So in this problem, we have to do 2 squared first, which is 4. Then we would do 6 times 4 is 24. In this problem, the volume is equivalent to the sides cubed, which means I have to take 3 of whatever the side length is. So 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27, and that would be the volume of the cube.